Let us study the discovery of the electron. See, the electron was discovered through cathode ray experiment, which was actually being carried out by many people, many scientists, but it was actually the Goldstein who did the complete study on this, and he came out with the properties of these particular rays which are coming out from the cathode in the discharge tube experiment, and he was the one who said there are certain particles which are making these rays. Later on, J.J. Thomson did the complete study on it, gave the charge to mass ratio of these particles and named these particles as electrons. I hope you must have done this cathode ray experiment or discharge tube experiment in your junior classes. Let me explain you this briefly. This discharge tube experiment comprises of a discharge tube which is having two electrodes like this one, and it is subjected to very low pressure and a very high voltage is actually given to this discharge tube. There is some gas filled in this discharge tube, and when this gas is subjected to a very high voltage, what happens is that what we notice is that suddenly, so this is the negative end of the battery, this is the positive end, this is what we have a negative end here, this is what we have a positive end here. Now when we plated this anode with the compounds like zinc sulfide, or which shows the phenomenon of fluorescence, or we coated the back side of this discharge tube here at the anode side, because we know this is the anode side. The side which is connected to the positive terminal is called anode, and the side which is connected to the electrode which is connected to the negative side is called cathode. So when we coated this anode with zinc sulfide, what we noticed is when this gas in the discharge tube is subjected to a very high voltage and under a very low pressure, this side starts glowing. Now the rays which are coming and which are making this side to glow are called cathode rays. Now after understanding what exactly the cathode rays is, let us see how the Goldstein studied its properties. See, these rays actually are not visible, but when we coated the backside of the anode with zinc sulfide, or when the anode itself was coated with zinc sulfide, what was found that when these rays got striking this anode, this side particularly starts glowing. It is due to the phenomenon of phosphorescence. When these particles strike, which are there in the arrays, strike the zinc sulfide, it produces a small spark, because of which this side starts glowing. Now Goldstein was very much surprised by these rays, and he did the number of experiments on these rays to conclude what exactly these rays are and what are their constituents exactly are. Now, the first thing which was done, that it was understood that since these rays are coming towards anode and it is actually making this side or the back side of the anode to glow, they are coming from the cathode, and that is why these rays are called cathode rays. So these rays are called cathode rays. Then these rays are traveling in the straight line. This was confirmed when they used a perforated, or the anode which is having small holes, and what was observed, these rays were able to pass through these holes and were striking the backside of this anode. It means what? They are always moving in straight line. Then a small object, opaque object, was placed in their path. Its shadow was casted on the backside or at the anode, which shows that they also cast shadow, or that particular area of the anode was not receiving any such particles. So if that means what? They can cast shadow. Then whether they are made up of any particles or they are just the electromagnetic radiations like a normal light, that was concluded by placing a paddle wheel at the center of this experiment. When the paddle wheel was placed in the center of this experiment and the rays were coming out from this side, they strike this paddle, the paddles of this wheel, and they make this wheel to rotate. Now when this wheel rotates, it means what? These rays are made up of small tiny particles. They are not just the electromagnetic radiations. They are having a particle nature. That is why they are able to move this paddle wheel. So these all were the few major conclusions which were made by Goldstein. Later on, in order to find out what kind of a charge they have and what is exactly their charge to mass ratio, J.J. Thomson did again some number of experiments on these rays. Like, what they did is, in order to confirm what is the charge on these rays, is an electric field was placed around this tube. If suppose this is the negative side and this is the positive side of the electric field, what was found that these particles got bent towards the positive plate. This ray got bent towards the positive plate, and when the zinc sulfide was coated on this side, it also starts glowing. This side particularly starts glowing, and not this one. So it means what? These rays gets deflected when they are pass through the electric field, and they always gets bent towards the positive plate. It means what? They are made up of the particles which are negatively charged. The J.J. Thomson, by the angle with which, or by the distance projectile or trajectory which they are forming and the distance they are traveling, J.J. Thomson was able to conclude or to calculate the charge to mass ratio of these particles. So these are the few experiments which were done by the Goldstein, and later on they were proved by the J.J. Thomson that these particles are the electrons, which are the constituents of these cathode rays. So in order to sum up the things, you must understand when this discharge tube experiment was done, that was done actually in order to make or to realize, can we make gases the conductors? And it was realized that when these gases are subjected to a very high voltage under a very low pressure, yes, they can be converted into conductors. The conduction of the current is taking place. Then Goldstein realized, wow, that once this is a conductor, it means what? There are certain charges are there. The rays are coming out of the cathode, negative charge from the negative electrode, and they are moving towards positive electrode. They called it cathode rays. And then after doing the number of experiments, it was concluded that these are the rays which are made up of negatively charged particles called electrons.